The Solar Basics module, Passive Solar Design, explained that the orientation of a building and the placement of windows and masts are necessary to maximize heat capture from the sun. In this video, we'll discuss how the layout of streets and lots through subdivision design can influence the potential for passive solar gain in individual houses and neighborhoods.
Hi, I'm Jeff Ward. I'm a retired planner. I worked in Atlantic Canada for more than 30 years.
And I'm Gareth Waslenko, a recent graduate from Planning School.
We're going to show a preferred approach for designing passive solar subdivisions. We're also going to show how to orient new houses on conventional lots.
And how to tweak lot design to maximize solar potential. To start, let's take a look at a SketchUp model of a typical one-story house.
SketchUp allows us to adjust for latitude, time of year, and time of day to simulate the angle at which the sun strikes the model at any given place or time.
In this example, the house is facing east and has morning sun. Notice how the shadows change through the day. One of the first things you will note is that the sun seems to dwell longer during the middle part of the day than during the early and late parts of the day. This demonstrates, as we saw in the Solar Basics course, why the middle part of the day is when we have the greatest potential to capture the sun's energy. Another thing to note in this particular case is that the front of the house, with most of the windows, only sees the sun in the morning, whereas the sunniest side of the house has only a small window. That's not a lot of potential for solar gain. Now let's look at a typical residential street with uniform street lines and lot lines running perpendicular to the road. Generally speaking, solar orientation is not one of the design considerations on conventional streets like this. This street happens to run east-west. At midday, the fronts are all in shadow, but of course the backs are in sun. Note how the houses on the other side of the street are all in sun. This would be a desirable street if you wanted to maximize solar gain. But simply facing the sun is not enough. You need to think about what rooms in the house get the sun. In this case, the two-story houses have lots of windows and an open floor plan. Light can penetrate into the room and heat can be felt throughout. The single-story house, however, has a garage, no light, and the room at the front of the house is a bedroom. Even though it faces south, the house does not benefit from its optimal solar orientation.
Gareth, let's talk about orientation a little more. I've got a map showing a few blocks in downtown Halifax. What can you tell me about this?
Well, they just look like ordinary city blocks.
Tell me a little more.
Well, they're rectangular.
Okay, and what direction are the streets running?
That looks like northeast, southwest.
Yeah, and there's straight streets. In a typical subdivision nowadays, we'd often build with curvilinear streets. But setting that aside, if I was to turn the map, what direction are they running now?
Well, I guess that's east-west now.
You know, that's perfectly optimized for passive solar orientation. All else being equal, I mean, setting aside things like slopes and connecting roads, do you think it's a more expensive project to build that way?
No, I guess not.
Exactly. It shouldn't cost any more to develop with an east-west orientation. The basic issue is that we don't typically build city blocks anymore. Straight streets provide the easiest opportunity for east-west orientation and to set up homes for passive solar. But they have other benefits too, and some places are now recognizing the value of blocks with short streets. East Hants, for example, now prohibits curvilinear road layouts. Especially when designed as small blocks, short streets tend to be more walkable. Rectangular blocks are also foundational to the new urbanism movement. Though straight streets may be ideal on paper, geography and topography often make designing streets in this way a challenge. But it might still be possible to design for solar by adjusting lots so they remain aligned to the sun. Here's an example from California. Notice how the residential streets run basically east-west and branch off the north-south spine. When you look at the lot lines and building footprints, you'll see they all align south, even on the curving sections. Incidentally, this plan also integrates an active transportation network into the design.
So we see that street orientation is important to solar subdivision design, but we're going to look at ways to incorporate solar orientation however the street is designed.
But Jeff, with or without passive solar orientation, subdivision design is complex. It requires considerations for vehicular access, slopes and drainage, water and sewage, telecommunications, schools, businesses, recreation, but then also density and profitability.
Absolutely, and somehow designers come up with layouts that maximize lot yield.
With these, you tend to get a uniform setback of homes, lots being perpendicular to the street, and street orientation dictating solar orientation, good or bad.
Isn't it the point to optimize lot yield in a subdivision and therefore maximize profit for the developer?
Yes, and the municipality is going to like it too. They want to maximize lot density, but it neglects consideration for solar gain.
So, in most cases, the convention of running boundary lines square back from the road ignores considerations for grades, views, slopes, and solar orientation?
That's right, often, but even conventionally designed subdivisions can give solar gain potential.
With large lots, there is usually no street line to conform to.
But with small lots, if you are reasonably close to an east-west orientation, up to 15 degrees off south, all homes can have a sunny side, whether it is the front yard or the back.
Absolutely. Just be aware you're not going to get much sun on the sides. But where lots do not face south, there may still be a way to improve access to the sun. Right from the start, you can angle the lots so they're not perpendicular to the street and stagger the setbacks to reduce shadowing of neighboring houses. This might also provide the house with a more panoramic view of the street. Another approach is to vary the setback from one house to another. This will reduce the shadowing effect even further.
Gareth, we're standing on Connolly Street in Halifax, standing in front of a couple of houses. I want to point out, notice how they stagger back and forth along the street.
Yeah, but it doesn't look like they were designed for solar.
No, they don't, but they do demonstrate that you don't necessarily have to build to a common street line.
So building to the minimum could limit the possibility to maximize solar access.
Yes, solar subdivisions would establish minimums, but they might also require the developer to stagger setbacks.
In 2012, Halifax's Environment and Sustainability Standing Committee commissioned a study to test how passive solar designs would impact setback requirements and lot yields.
Here's an example of one of the subdivisions analyzed. This subdivision was approved by HRM in 2011 for 46 lots, with an average lot size of about 1,000 square meters. To apply passive solar design criteria to the subdivision, the analysts did not change the road network or lot layout, but instead adjusted the building footprints to orient the long side of the buildings to face south. Also, they staggered the houses one house deep at intervals to prevent shading.
And also note, they did not need to make any changes on the east-west street.
The analysis found 23 places where the changes impacted setback requirements, which meant these adjustments for solar orientation could not be permitted under the current land use bylaw. In the next step, they manipulated lot lines and building footprints so that passive solar criteria were met while staying within the confines of the setback requirements. The result was a net loss of 9 lots, which amounted to a 20% reduction in lot yield.
Most developers would find that loss pretty unacceptable, but another step might have been to take a site planning approach at this stage.
This means looking at how each house might be uniquely positioned within the lot, coming as close to your goals as possible within the limits of the bylaw. Obviously, you may need to compromise from time to time, but in this way, you might lose fewer lots than you think.
The report recommended passive solar design requirements on larger rural lots and suggested consideration be given to more siting flexibility on smaller urban lots like these.
Note too, the east-west streets all achieved the solar orientation goals we're looking for without any changes. That's another big takeaway. Land development is a substantial contributor to climate change. This comes from urban sprawl, the extensive use of mechanical systems in buildings, heat islands, and so forth. Planning for passive solar gain is one way to help mitigate this.
To recap, to maximize our potential for passive solar gain, we want to design streets in a predominantly east-west axis, establish lots and setbacks that enable passive solar gain, orient houses and windows as close to the south as possible, and avoid shading neighboring houses at key periods of potential solar gain.
And for designers, if you're going to plan subdivisions with passive solar principles in mind, do it from the very beginning. when designing streets, lot layouts, and the homes themselves. As we saw, once these are established, so is the possibility, to a large extent, to optimize passive solar gain.
And finally, remember that old adage, you can lead a horse to water, but you can't make him drink. You can require solar orientation for streets, but builders also need to design buildings that take advantage of that passive solar orientation.